An infinite ladder is constructed with 1 ohm and 2 ohm resistors as shown in figure. We have to calculate the effective resistance between point A and B. Now since we have repeated 1 ohm and 2 ohm resistors and there is an infinite ladder, so it hardly matters if we'll neglect any single 1 ohm or 2 ohm resistor. So what we assume is that even if we neglect the 1 ohm and 2 ohm resistor, the resistance will be same. So first, if we neglect for an instance this 1 ohm and this 2 ohm resistor, the net resistance of the remaining circuit will be R equivalent that we assume. So if we assume this, the circuit reduces to this circuit. This is my R equivalent. This is the 2 ohm that I neglected, the 1 ohm that I neglected earlier. My point A, it is connected to a battery of 6 volt, and here is my circuit. This is my point B. Now to calculate the effective resistance, we have R equivalent and 2 in parallel. So let's say R dash, that will be given by 2 R equivalent divided by 2 plus R equivalent. This equivalent is in series with this 1 ohm, so I can write R equivalent because the net resistance will be equal to R equivalent. So I have R equivalent equal to 2 times of R equivalent divided by 2 plus R equivalent plus 1. So on solving this equation, I'll get a quadratic equation, and we'll calculate the quadratic equation first. We have R equivalent into 2 times of R equivalent is equals to 2R equivalent plus 2 plus R equivalent. So I have 2 times of R equivalent plus R equivalent square is equals to 3R equivalent plus 2. I have R equivalent square minus R equivalent minus 2. This is my quadratic equation. Now solving this quadratic equation for R equivalent, I get the value of R equivalent as 2 ohm. That is my answer for the first part. In second part, I have to calculate the current that passes through the 2 ohm resistor. So I'll apply Ohm's law, that is V is equals to IR, to calculate the net current flowing. So I have a potential V is equals to 6, current that I have to calculate, and resistance is 2 ohm. So I comes out to be 3 ampere. This is the net current flowing. So this will be the current coming out of the battery, that is 3 ampere. Now current I is coming over here. Now since R equivalent is also equal to 2 ohm, so the current will be divided equally because resistance is same. Potential difference across the two resistors will be same, so the current will be same. So current will be equally divided, that will be I by 2 over here and I by 2 over here. So the current that passes through the 2 ohm resistor will be equal to, so 2 ohm resistor will be equal to I by 2, that is 3 by 2, that is 1.5 ampere. That is the answer.